We are talking about virtualizing Mac infrastructure at scale. My name is Shawn. I'm from MacStadium. This is Paul from Dropbox. Why don't you introduce yourself?
I'm Paul from Dropbox. I work on the virtualization team. We provide infrastructure for running different types of workloads on VMs and containers, and we work very closely with the CI team at Dropbox.
And I'm Shawn Lankton. I'm from MacStadium. I lead our sales, marketing, and customer success teams, engineer at heart, and spend a lot of time with folks like Paul thinking through what solutions work and helping them scale out. So before we get started talking about what Paul and Dropbox have done, wanted to learn a little bit about who's in the room here. So raise your hand if you would consider yourself more of a DevOps person. Okay, a few people. And raise your hand if you're more of an Ops IT person. That's about what we'd expect for a VMware conference, so that's great. Obviously, everybody has a little bit of DevOps interest, which is why you're here. Get a broad range. How many folks would say that they have advanced DevOps going on in-house? Cool, few. And then, absolute beginner, not sure, you're just kind of getting started. All right, we'll put everybody else in the medium bucket. So that's helpful. And then, let's a little game that I like to play called How Many Macs. Raise your hand if you've got at least one Mac as part of your build infrastructure somewhere in your company. Should be probably everybody. Under the desk or in the data center. So keep them up if you've got more than 10. Okay, more than 50. Losing some hands, more than 100. One left, more than 200. More than 500. Wow, we got some competition here, so that's awesome. I think as we get into this, the scale of the Dropbox environment is at least on that order, so should be some good lessons for everybody in the room. Just quickly on the agenda, we're going to talk about just really quickly why Macs are required for CI for Xcode. Then we'll talk about Dropbox, what they're specifically doing, how they got started, challenges that they had as they scaled up, and then lessons learned and some ideas. We'll have time at the end for questions. So the reason that we're all here is because Apple hardware continues to change the world. You want to be able to put your app in somebody's pocket, on somebody's laptop. And we're in this a space where we have three colliding trends, where we've got everything is moving to cloud. People are adopting DevOps and CI as changing the way software is developed, and Apple's ecosystem of 1 billion users continues to grow and get stronger. When you smush those three trends together, you are left in a space where you're sitting in a conference room trying to figure out how to actually orchestrate this infrastructure at scale. Just a quick review about continuous integration. So this is the typical continuous integration loop. Really the DevOps loop more specifically, and really we're talking about the continuous integration part, which means that you're going to build on every commit, test on every build. It helps you catch errors faster and give you a faster time to value for the code that your developers are working on. When you are talking about doing continuous integration for apps on Apple endpoints, iPhones, iPads, Macs, Macs are required in a way that they aren't for any other build. Every build in the Apple ecosystem runs on Xcode. Xcode only runs on macOS, and macOS only runs on genuine Apple hardware. So that's Mac Pros, Mac Minis, MacBooks, an Apple II that you may still have. But and then if you're talking about building Mac apps or iOS apps and you want to test them, you can only test those on Mac machines as well. So whereas you may have a set of CI infrastructure that works great and scales all the way out on your favorite public cloud provider of choice, you can't do that in MacWorld, which is why we're here. And so Paul and his team have found some really innovative solutions on this, and we wanted to spend some time talking through them. Paul, can you get started by talking about what you guys do at Dropbox?
Yeah, so a bit about why we need Macs at Dropbox. We run a few products. We have a few products that run natively on Mac OS X and iOS. A bit of context in case people aren't familiar. Dropbox started off as an application that helps you organize your files across multiple devices and makes sharing files easy. And then over the years, it has gained a lot of like collaboration features, especially in the business offering. Paper's a bit newer. Teams at Dropbox use it a lot for things like just taking notes or even writing full design docs to share out with teams. We also use it like in meetings to take notes and like assign to-dos to people. So all of these run natively on like Mac products like iPhones and macOS.
And tell us a little bit about the team that you're supporting and the scale of what you're trying to build.
Yeah, so we have hundreds of developers working on these products. To support the CI system for them, we have hundreds of Macs. Every day we run like tens of thousands of build shards.
And what is a build shard?
Yeah, so if you were to run our full test suite, it would take many hours. But we want to get feedback fast to developers. So we end up sharding each build to run the tests faster.
So you take each build, which can, the compile step is sort of blocking, and then after it's built, the tests run in parallel across a bunch of different devices to finish.
Yeah.
And why do you have so many hours of tests to run for your apps?
Yeah, I think a few factors contribute to that. One is the number of engineers we have. Like the more engineers you have, the more commits and more builds you run. And then there's like the number of features and tests. The more features you have, the more tests you have. Also, there's the fact that we support multiple OS versions, so we have to run end-to-end tests on, say, multiple OS X versions.
Right. Yeah. And something that integrates as deeply into the operating system as Dropbox does means that those tests are spread across a whole bunch of different hooks and nooks and crannies of all of the different endpoints.
Right.
Do you want to just talk really quickly too about your high-level tooling and how you guys think about that?
We can talk about the general CI system.
We'll touch on how you built it in the first place, how it works for everything. Get into how you implemented that at first, and then what growth kind of did to the system.
Mm-hmm. Yeah. So this is kind of what our CI system looks like at a high level without considering Macs. So I mentioned that we have like tens and thousands of Mac shards a day. That's actually only a fraction of what our CI system supports. That we have to run builds for like Windows and server-side code also, and we have a Linux client and Android. So this is generally what it looks like. Engineers commit code into repos. Our CI service automatically detects the changes and kicks off the relevant builds according to that. Job schedule. So the CI service then shards out. So you have like a big suite of tests. You want to run them in parallel, so you shard them out. A job scheduler picks up these shards and works with like the resource manager, which knows about the pool of workers you have. Which kicks off, and the job scheduler then kicks off the job on the worker node. So the worker node is responsible for, in general, spinning up a container or VM to run the load on and report results back to the CI service. In most cases, we can spin up a local container on the worker. It's a bit more complicated when we need Mac VMs. So
this is what you built.
Yeah, so to manage our Mac VMs, we're using vCenter. In our CI system, instead of allocating a local container on the worker node, we end up allocating VM through vCenter.
And there's a lot of different steps here. Why why go through all this extra work to sort of pull this into the same structure as everything else?
One reason is to keep the integration the same with the CI service. So we still have the same generic worker agent that's controlling what's running inside the container/VM and reporting results back to the CI system. The reason for some of the extra pieces down there, so the job schedule and resource manager, if you're familiar with like Jenkins or Mesos, you can think of those as that. The resource manager below, that's like a layer we built, a thin layer we built on top of vCenter. vCenter does a lot of stuff, but we need a pretty simple API. So that's what the VM Resource Manager kind of provides us, the ability to easily allocate VM.
So in a way, it's acting like a plugin that you might have for a Jenkins or something. It's just more custom because of what you guys are building.
Yeah.
Talk about how that vCenter actually works and integrates with your Macs.
Yeah, so diving deeper into what our vCenter setup looks like. So we run a single vCenter with hundreds of Mac hosts. They are organized into multiple clusters for a few reasons. One is that vCenter has a limit on how many hosts you can have per cluster. Not a great reason. The second is we use the clusters to isolate to control how much resources certain workloads use. Like we might want to limit certain, like our iOS workloads to a certain set of Macs.
Are there any other differences between the clusters, or is it pretty much identical infrastructure across?
It's pretty much identical infrastructure. All the hosts look the same. They can be swapped from one cluster to another without problems.
Do you try to maintain equal number of hosts in each cluster, or does it vary?
We don't care so much on the per cluster level. We just care like how many hosts total we have for like maybe iOS.
And the data stores along the bottom are connected to all the hosts in this diagram. Talk about how that storage works and what's living on the data store.
Yeah, so all the data stores are mounted on every host. We use the data stores primarily for sharing templates. So the hosts themselves actually have SSDs on them, and we run VMs using the SSDs. And we use a lint clone to get the templates off of the data store.
So the templates are living on the data store, and the VM storage volumes are living on the SSDs.
Yes.
And is there a copy when you actually spin up the VM? Does it have to copy it from the data store, or does it?
We do a link clone, so it's pretty quick.
Can you talk about linked clones for people who may not know how that works?
I think of it as read as needed. Yeah, from the template.
And that is often the secret.
Copy as read it.
Yeah, to how to build VMware VMs that act more like containers. Linked clones are the secret. If you've been looking, find linked clones, and there's a lot of documentation that will take you to the right place.
Yeah, I guess one note I forgot to mention was that so our shards are we spin up new VMs for every build shard. They live for like a minute to tens of minutes to hours. So these are very short-lived VMs. If you have minutes-long VMs that live for like minutes only, having fast clone time is pretty important.
So this is the initial design. Talk about what happened. Basically, how did this go from the first cluster to having many clusters, and then where did you start to see that growth sort of?
Yeah.
Where did that growth take you?
This. I think this is what our vCenter configuration looked like about two years ago-ish. That's when we started running into more problems as we added more hosts to our cluster. one of the issues we saw was a lot of EXXI crashes on Macs. We don't know why, but we don't know why, but it was causing us a lot of headaches. That made coordination between the teams involved a challenge. So if you think about the entire system, it's not actually one team that's managing all of this. So we have like a team working on CI. There's a team working on managing vCenter, and then there's a team working on the Mac hardware in the data center. And as we scale up, we found that we were stepping more on each other's toes. Was one of the problems, especially when there are problems like EXXI crashing on Macs all the time.
And when you say ESXi was crashing on the Mac, describe what that means for people who have not seen ESXi crashes.
Yeah, so we've seen different symptoms. We've seen purple screens of deaths. We've seen issues where EXXi is like saying some state file is corrupt, and we haven't found a solution for what to do when that happens besides reinstalling EXXi.
Before we get into some of the tactics that you use for that, talk about the developer feedback when you have a CI system that has crashing hosts in it.
Yeah, so it feels pretty bad to be a developer when you're trying to commit code and it takes hours before the test run and your code can go into master. And sometimes after hours you learn that, oh, there was a flake. And why was there a flake? It was because of like some kind of CI infrastructure issue. It's that doesn't feel good to be a developer in that kind of environment.
Right. So a lot of developer frustration when they can't trust their CI infrastructure to be reliable.
Yeah. And if you're considering like CI workloads, a lot of times you're going to have tests that are flaky. It's extra confusing when you can't trust the underlying infrastructure also, because then you're questioning, is my test actually flaky or is it the infrastructure? So it's really important to have reliable infrastructure that you can trust.
Helps you push back when developers say it worked on my machine.
Oh, yeah.
And so, and this was, so you're running into these sort of scaling issues as you were deploying these Macs in your data center. Where were some of the places you went to get help?
So for like the EXXi crashes I mentioned, we try talking to different people like MacStadium, VMware, trying to and also researching online like whether others have run into these crashes, but we didn't find a very good solution. We did, however, spend some efforts improving how we coordinate repairing these machines internally within like the three teams I mentioned, like the CI team and the data center team and the people running vCenter.
So here's the sort of the diagram you put together. Can you take us through what that collaboration ended up looking like in terms of an internal workflow?
Yeah, so to avoid people like working with vCenter and working on the Mac hardware themselves touching machines that the CI system is using, we introduced like a repair cluster where we have a service that just detects them when machines are bad, move them to repair, and those are the only machines that data center people can touch. And when they're done repairing our machines, they put it into a spare cluster where our service like smoke tested before putting it back into production usage. And that's the smoke testing is important because what if the repair didn't actually fix the problem? Or maybe there's some misconfiguration of the machines. Yeah, we.
About how many hosts were typically moving through this cycle for you guys on a typical day or week?
For us, about I would say 1% maybe.
So 1% of hosts were always out of commission and rotating through these various baskets.
Mm-hmm.
And when you're operating at the scale you are of hundreds and hundreds of hosts, how much time was that taking your data center team to repair?
It's probably one person. One person
full time.
Yeah.
Job. Yeah. I'm sure that was a very happy person. So you had talked about some of these internal scaling issues. You mentioned the Mac host failures and the extra load that creates on the data center team. Talk about some of the other pieces that were holding you back with the infrastructure as it was deployed just fully at Dropbox.
Yeah. So besides the high workload for the data, I guess as you mentioned, the reason why this is a high load on the data center team is because our fixes usually reinstall EXXI on Macs, which is not. We've spent some time trying to automate that, but it's not fully automated. We found that we need to have at least one person hold like some key while rebooting machine to install EXXI. When hosts crash, we need someone in the data center to do this, and we had to. After that, we had to add it back into vCenter and reconfigure the host. So other issues we ran into. Over the past year, we started seeing slowness in our vCenter setup. The vCenter UI is usually really, really slow during the day when there's a lot of load. Every few weeks, vCenter will get so slow that we would just have to reboot it before it starts making any more progress. We don't know exactly why, because we don't have good telemetry on what vCenter is doing. What we know is that the APIs get really slow sometimes. And it might be because we're abusing the vCenter API. Maybe we're just sending too many requests, overloading it. Yeah, we're not sure.
Mm-hmm. So that's when you started to say, hey, look, we're having these issues. Our need is continuing to grow. You reached out to MacStadium. I guess we'd been having conversations with you guys for a while, trying to help problem solve it, and eventually it became time to scale. So talk about what finally put you over the tipping point there.
Yeah, it was a mix of having to deal with all these issues and also needing to, we're constantly hiring engineers, so we need to grow quickly. We need to add capacity more quickly. Adding capacity for us is much harder, I would say, than asking MacStadium to just give us some racks.
So I guess once we built that first cloud for you and deployed it in our data center, you guys had to do some coding on your side to actually make sure that you could utilize MacStadium infrastructure as well as your internal infrastructure. Talk a little bit about how you adapted that VM resource manager.
Oh yeah, that was actually a pretty simple code change. It was kind of nice that we already had this extra layer on top of vCenter, so we just had to change it a little so that we can allocate VMs on either our internal vCenter or the MacStadium one.
And so basically, because you already had this sort of middleware that was acting as a plugin almost, they could direct a vCenter. It was flipping a bit to tell it to send to vCenter internal or vCenter at MacStadium.
Yeah.
And what were some of the benefits that you saw once you had that in place?
Much easier to scale. If we were to try to add racks in our own data center, we would have had to plan for the space much earlier. We would have to figure out how to buy more Macs from Apple. Whereas with MacStadium, we talk to finance, we get it approved. We talk to MacStadium, we get a few Macs in a few weeks. And so much more flexible scaling. We're also reducing load in our internal vCenter by spreading load across 2 big vCenters now, and also more expertise available to us on Macs and vSpheres in general. I would say internally we don't have a lot of vCenter experts, nor experts running, having Macs in like the data center. With MacStadium, actually it's our first time. For the first time, we tried going from 6.5 to 6.7. I think we found one issue of link clones that got fixed a few months after VMware.
And I have to ask, now that you have Macs running in the MacStadium cluster, how many of those are consistently purple screening on you and causing host issues?
None. I don't know. I don't know what the difference is. Yeah, I've been hearing that one theory is like running EXXI on SSDs versus USB sticks, but don't know yet.
Yeah, definitely a lot of hard-fought lessons in deploying thousands and thousands of Macs for customers that can give some benefits. Another piece of moving the infrastructure to MacStadium was thinking about how you use networking and giving you the ability to run some different tests on how you connect storage. Can you talk a little bit about both of those?
Yeah, so connecting with MacStadium was actually pretty painless. We had the option to privately connect, so no traffic going over the internet. We have like dedicated guaranteed bandwidth. So that was pretty nice and straightforward. On the storage side, we actually experimented a bit when we were integrated with MacStadium. So I mentioned before that we use SSDs along with like network attached storages. With MacStadium, we decided to try out what if we eliminated SSDs. It's simpler to just use data stores outside the host. And we found that we care about write latency a lot in our workloads, and that didn't quite work out for us. It was actually mostly okay at the beginning, but with some experiments, we found that it's probably expensive to scale up with just network attached storages.
Because we have a partnership with Pure Storage, we were able to deploy several different storage technologies, several different storage arrays in a POC environment, and allow Dropbox to actually benchmark the different solutions against one another. And as Paul said, in a workload like Dropbox where there is a huge amount of writes in order to test the app, because given the app's whole purpose is writing to hard drives, it turns out the internal SSD with the network attached NFS data stores was the right solution, but which is the solution that you guys had come to internally, but it's nice to be able to prove that out as we think about how to continue scaling the environment with you. So I think that gets through most of the overview of the solution that Paul and Dropbox came up with. Wanted to spend a few more minutes talking about lessons learned, next steps, and some advice. So talk to us a little bit about what you know looking back on this.
Yeah, so I think I've been working on this for about 2 years now, maybe a bit less. I was completely new to vCenter then. Well, when I first looked at the vCenter API, I thought it was a bit scary. A lot of tabs, a lot of options. I've learned a bunch about vCenter and EXI since then, and I've learned that there are a lot of features, but I still feel like I'm not an expert. I still feel like a newbie when it comes to like vCenter stuff. But I've also realized that you really only need a few features. In our case, you really only need a few features to make vCenter work for us well. And it's mostly some way to do like fast clones with link clones, to spin up VMs, a way to like terminate VMs, a way to organize templates and manage hosts.
So you talk about overloading the vCenter. What are some things that, looking back, you would advise these guys to look out for as vCenter is becoming overloaded so that they can get some early warning signs?
Yeah, so I mentioned before that we don't have very good telemetry on what vCenter is up to. It's a bit of a black box to us, so we don't have a lot of, we don't really know what the limitations of vCenter is. Like, we don't know how many hosts or VMs it can really support, but usually what happens is the API starts getting really slow. And I think one thing we can do to help out, even though we don't know what vCenter is doing, is to make sure to back off when vCenter seems overloaded.
And so, what that says to me, and as you've scaled out to MacStadium, now that you have multiple vCenters, it's possible to shift loads around. So when a vCenter is getting overloaded, you can back off of it, which allows you to restart it, repair it, give it time to clear cache, versus only having one vCenter that you have to hammer. So being able to move workloads around is helpful.
Yeah. I would say be ready and comfortable to spin up more vCenters.
And then proactively searching for host issues. What are some things that you guys look out for in your smoke tests? And what are some, why be proactive about it versus reactive based on what you've seen?
Mm-hmm. Yeah, I mentioned before that it's really important to be able to trust the underlying CI infrastructure. Like, it really doesn't feel good to have your build fail because a Mac goes down. So once we detect issues with a host, like we detect a few shards fail, we will immediately rotate it out, smoke test it. That's really important for our reliability. Some things we look for when we smoke test, it's just some simple stuff like, does memory operations seem fast enough? Do disk writes and reads seem fast enough? Is the host configured properly, like with all the data stores it needs? Yeah.
And we've also been talking about what's next for Dropbox as you continue to build out the CI environment. Obviously, long list of things, but as you look ahead, what are the most pressing issues for you?
Yeah, so we're probably looking at like how to scale vCenter further. I mentioned before that we're still running into some problems with like overloading vCenter. So maybe how do we handle even more vCenters? Also, how do we improve reliability of EX6i running on Macs? And looking for like how do we work with like the new Macs?
Everybody wants to know.
Yeah.
So I think that's it in terms of what we put together for you guys. We've definitely got some time left, and I'm sure there are some questions in the audience, which we'd be more than happy to take.
So when you're testing out your API calls, are you doing that manually, or have you automated that in some way to tell how, like, when it starts to slow down?
So the question was, when you're testing API calls, are you doing that manually, or do you have that automated so that you can determine when vCenter is starting to slow down?
So I'm assuming you're referring to how we monitor like when vCenter starts to slow down. We have like vSphere monitoring services just pulling vCenter for various stats, including like, is it up? Is it responding quickly? We also collect stats about like how many VMs are running from there too.
When we deploy these for other customers at MacStadium, we have Logic Monitor that we deploy as our internal monitoring solution. And so with vCenter collectors, we can get really quite a bit of data on vCenter health, how much space is being used in that VM that vCenter is running in, make sure that the infrastructure it's running on looks good and that it's up and responsive. Because we are locked out, we don't know much more than that in customer environments. But we can configure Logic Monitor to send those NMS alerts to customers via tickets so that if you're deployed at MacStadium, you can start getting those alerts proactively. And hopefully, our engineers, which are on 24/7, will already have noticed that and started working on the problem.
How does it support the latest generation of Apple?
Yeah, the question is, how is support coming for the latest generation of Apple hardware? That is a question that I'm sure somebody here could answer better than I could. There is, the state of the state as of today, August 2019, is that Apple has released a new piece of custom silicon that they call the T2 chip, which is a security chip, but also a super fast SSD controller. The security part means that it won't run any operating system on the Mac other than macOS. Operating systems like ESXi, for example, are blocked. So our understanding from close working relationship with VMware and Apple is that they are working on it. And then any information beyond that, I think that they would kill me if I shared. So, yep.
So when you were when you started with VMware and vCenter, did you consider any other tools for virtualizing the Macs? I mean, there wasn't as many back 2 years ago as there are now. So I'm curious if you considered other tools, and now that there are tools that run on native Apple hypervisor, if you've looked at those as well.
Yeah, the question is, had you ever explored any alternatives to VMware for creating VMs on Mac?
So, we haven't. So I joined the team like 2 years ago. We haven't considered a different type of virtualization for Macs yet, but that's certainly a possibility going forward.
Speaking from our perspective, I'd say the vast majority of our customers are still using VMware. And some customers are definitely looking into some of the other solutions that I'm sure you're alluding to, which I won't name here. But there are, some of them are very new. Some of them are supported by kind of 5-person startups, which can be spooky. And so, we see a lot of customers wanting to test out the latest and greatest, but also a lot of folks relying on the fact that VMware is a proven solution with the ability to scale all the way out. And a lot of really enterprise support, security features and things like that.
Do you still get that support on the Mac side?
You go first. The question was, do you still get the support on the Mac side?
We do get answers. We do file tickets of VMware support. We do get answers. I've only more recently been working closer with them on why our Macs are crashing so much on the EXXi, but that was fairly recent. I'm sure my team has talked to them about it a while ago. Haven't found a solution yet, but they are responsive.
Yeah, from the MacStadium side, I'll give a shout out to Shawn in the back, who's our TAM with VMware. So he's in our offices, a couple times a month at least, helping us work through customer issues or issues that we've discovered in our own testing. We've got a bunch of highly certified VMware engineers that are all over this conference. And so one of the things that we can help bring customers is a lot of that expertise and a lot of that troubleshooting with Mac issues, which frankly most people in VMware are not that familiar with, let alone outside. So it's definitely a challenge, and it's one of the things that we think that we can help bring to the conversation in addition to just actually, spinning up the hardware and making all of that work.
VMware does say it's supported, right, for running?
Yeah, absolutely. These are all of these, the Mac Pros and all the Mac Minis except for the 2018 Mac Mini are on the HCL. They're fully supported. So they are, officially supported. These are officially supported solutions. It's not like we're hacking this together. They're officially supported, but Apple has a lot of weird little nuances to make this work. And with a system that's as robust as vCenter and all of the features that come with that, knowing when to open up the second dialog and click advanced and check that, make sure that one box is checked, can really mean the difference in accelerating performance or having scaling issues. Yeah, so the question was, how do you deal with the fact that Apple is not making sort of enterprise data center rack mountable hardware? It's really desktop hardware, and you're trying to put it in a data center. So I know that Paul doesn't work in the data center, and I think that the teams there, the teams at Dropbox, long before Dropbox was a customer, we built a relationship with their data centers team. Actually, before we even met the CI team, we were having conversations with them periodically to sort of share some of our best practices. And I think that, as Paul alluded to in his talk, can be challenging for a data center team to deal with these. A lot of data center technicians do not like having to walk over and push a button on a Mac or hold down a key while they're reinstalling software. And frankly, it gets a little bit worse with the T2 chips on the newer Macs. They block even some of the automation that was possible on the legacy Mac generations. Parts of the ways that we've solved that. So with MacStadium, every Mac Pro that we deploy into a VMware cloud, or any cloud for that matter, will have custom upgrades that we install that allow you to have redundant NIC, redundant storage fabric, redundant power supplies. So we build that all into a custom sled that we've designed, we manufactured ourselves. So if you look in our data center, it kind of looks like a data center. You have walls of all consistent hardware, you've got all the cabling on the back, it's all nice and tidy, it's all fiber, which goes high speed into dedicated top of rack switching, it's all the latest and greatest Cisco stuff. So that gives us a lot of advantages because our infrastructure looks and feels a lot more like typical enterprise infrastructure. The other part of it that we've invested a ton in is training our data center staff. So most of our data center staff are certified Apple technicians, which means if a piece of hardware does go down, they can pull it out, they can replace the broken parts, they can put it back into service. And they're frankly used to dealing with Apple infrastructure. So it's not that you're bringing donuts and trying to beg the data center team to please keep walking over to those Mac Minis and rebooting them whenever I ask you to. It's, our data center staff knows about it. Reboot ticket comes through. We actually put put some of the infrastructure on IP PDUs so that you can actually power cycle it with a API call. So there's tricks like this that help take that desktop hardware and make it act a little bit more like fully automated infrastructure as code. And certainly, some of that's human. Some of that is custom designed metal racks and port breakouts. And some of it is working with the right kind of automation layer like with VMware so that you can send API calls and actually have the Macs respond. Other questions? Okay. Well, thanks everybody for coming. Really appreciate your time here. Hope that you got something valuable from this. Paul and I will be around if there's questions that you didn't want to ask in public. And you can always find out more by looking us up. You have both of our contact information here. If you want to learn more about MacStadium, it's macstadium.com. Tons of information there, and we have a big team of people who are all ready to help you out.